This video is about understanding and applying slope on a coordinate plane, determining the distance between ordered pairs, and finding the midpoint of two ordered pairs, and find the endpoint given a midpoint. So first let's talk about what a midpoint is. A midpoint is a point that divides a segment into two congruent segments. So another way to think about it is that it's cutting it in half. So to find the midpoint, we take the average of two numbers. So in our box here, we have the midpoint formula. To find the midpoint, we take the average of the x's and the average of the y's. So we add our x coordinates together, divide by 2. We add our y coordinates and divide by 2. So in number 1, we need to find the midpoint. So to find the midpoint, we're going to add our x coordinates together. Remember, it's always x comma y. So we have 3 plus 11 divided by 2, and 7 plus -5 divided by 2. It does not matter which one you consider your x1 and your x2, so I just go in order of how they're written from left to right. So 3 plus 11 is 14 over 2, and 7 plus -5 is 2 over 2, and then reduce my fraction, so this reduces to 7, 1. So my midpoint has the coordinates of 7, 1. That's the middle point between coordinates A and B. So let's try again looking at C. So I have -4 plus 8 over 2, comma 8 plus -9 over 2. So my first coordinate, I get 4 over 2 and -1 over 2. 4 over 2 divides to 2, and I can't reduce this fraction, so I'm going to leave it as -1/2. This is my midpoint again. Now let's try going the other direction. So you're going to have a midpoint. You need to find what the other point is. So there's two ways to do this. You can make it into a table. And so to make it in my table, I have my x, y's. So I have my A point. I always put my midpoint in the middle, and then I'm looking for my other point. So I have 4, -2, 2, -6, and I'm trying to find this other coordinate. So then what I would do is I would look at how are my y's changing. So my y's changed by -4, so I use that same change. So -6 minus 4 is -10. And when I look at x, from 4 to 2, I went down by 2. So again, I'm going to subtract 2. So my other coordinate would be 0, -10. Another way to do this is we can just draw a line. So I have point A, my midpoint, and my other point. And I know I cut my line into two congruent parts. So this part is 4, -2, and this point is 2, -6. And I can just look at how are they changing. So x is changing by -2, y is changing by -4. So I can just subtract these from here. So 2 minus 2 is 0. -6 minus 4 is -10. So pause the video and try number 4 on your own and then check your answer. Something to be careful about number 4 is that remember M is your midpoint and B is the other point. So my midpoint has to be in the middle of the table or the middle of my line no matter which way I do it. So I notice my Y's changed by -8, my X's changed by 5, so my new point is 10, -9. Distance formula. Distance formula is used to find the length of a segment. So we can sometimes see this called distance. You might also see it called length. So the distance formula, or length, is always a positive number, and it's equal to the square root of the quantity x minus 2 squared plus the quantity y2 minus y1 squared. So you're taking the square root and you're subtracting your x coordinates, squaring them, plus subtract your y coordinates and square them. So in number 5, I have my square root, parentheses. It does not matter which one is x2 and x1. So I'm going to call this x2 because it's the second coordinate. This is x1 because it's the first coordinate. So I have -3 minus 8 squared plus, remember, y2 and y1 must come from the same coordinate as x2 and x1. So for my y coordinates then, I have 5 minus negative 12 squared. So first simplify inside your parentheses. So we get negative 3 minus 8 is negative 11 squared, plus 5 minus negative 12, that's really 5 plus 12. So we get 17 squared. Then our calculator, we're going to square those numbers. So 11 squared is 121, plus 17 squared is 289. Add those two numbers together, and we get the square root of 410. If it asks for a decimal, then just do second square root of 410, and our decimal is 20.25. Make sure you follow your rounding rules. So let's try number 6. So we have x1, y1, x2, y2. So in our distance formula, it's the square root x2 minus x1 squared plus y2 minus y1 squared. So 3 minus negative 2 is 5 squared, plus negative 1 minus negative 5 is 4 squared. So 5 squared is 25, 4 squared is 16. When I add those together, I get the square root of 41, which as a decimal is 6.40. Let's review slope. So remember that slope is a ratio that compares the change in the y-coordinate to the change in the x-coordinate. So it's always y change over x change, rise over run. This equation for slope is y2 minus y1 over x2 minus x1. So in number 8, my y-coordinates go on top. So this is going to be y2, this is going to be y1. Just because they're written first and second. So I have 11 minus 1 over x2 and x1 come from the same ones as the y1 and y2. Negative 6 minus negative 4. And then I reduce. So 10 minus 1, or 11 minus 1 is 10. Negative 6 minus negative 4 really means plus 4. So this is negative 2, which reduces to negative 5 over 1. Or we could just say negative 5. Number 9, I'm going to do my y2 coordinate, negative 8, minus my y1 coordinate, negative 5, my x2 coordinate, minus my x1 coordinate. So when I simplify here, 8 minus negative 5 is 14, 7 minus 3 is 4. This is not divisible, but I can take a 2 out of each, so this reduces to 7 halves. Number 10, looking at our table, we know we have a positive slope because our line is going up. So remember, it's rise over run. So how much did I go up on my graph first? So from the first point to get even with the second, I went up 1, 2, 3, 4. So my rise is 4. How many did I move over? 1, 2 to arrive at the next point. And this reduces to 2 over 1, or 2. Now, number 11 is a little more tricky. So we're given our slope 4/3, and we're giving our point 5.3 and K11, and we need to find K. So we're going to set up our slope equation first. So looking at the points, we would have 11 minus 3 over 5, or K minus 5. We use K first because K came from the 11 coordinate. So when I simplify this, becomes 8 over K minus 5. We're going to use this and set it equal to our slope and solve a proportion. So we have 8 over K minus 5 equals 4/3. So we're going to cross multiply. So 4 times K minus 5 equals 8 times 3. So distribute 4K minus 20 equals 24. I'm going to add 20 to both sides, so 4K equals 44, and divide by 4, so K is 11. So our missing coordinate then would be 11. And you can always go back and double check. If I put 11 in here, this would get me 8 over 6, which reduces to the slope 4/3. Last, we're going to talk about partitioning a segment. So in number 12, find the points A, B that would partition into a segment with a ratio of 2 to 1, given the points 5, 9 for A and -4, -3 for B. So we're going to graph those points first. So A is at 5, 9, and B is at -4, 3. We're going to connect those to form a straight line. Now, find the slope. So remember slope, we can use our slope equation, y2 minus y1 over x2 minus x1. So we would have -3 minus 9 over -4 minus 5, which is -12 over -9, and that reduces to 4/3. In B, we want to find two new points that would divide the line into a ratio of 2 to 1. So what we want to do here is we want to look at how many pieces we really have. So 2 plus 1 is 3 pieces that we're going to try and cut our line into. So what we want to do then is we want to take the slope that we originally had. So I want to use this slope. Because they're both negative though, I can make them positive because I know my line is positive. So I'm going to take my original slope before it was reduced and divide by the three parts, which gets us our reduced slope of 4/3. This doesn't always happen. That's why I want to make sure we're dividing by those points. Then what you're going to do is you're going to use the slope correctly from point B. So you're going to go up 4 over 3. This is our new point C. So this would create the segment into a ratio of 2, because A to C is longer, to 1, because C to B is shorter. So our coordinates of C would be -1, 1. Now we're going to do the same thing from A, but we're going to use the opposite slope. So instead, we're going to go down 4 and right 3. So from your other endpoint, you always use the opposite slope. So now my B coordinate, my D coordinate would be 2, 5. In number 13, we need to find how to divide the segment into a ratio of 1 to 3. So first we're going to plot our points again. So A is at -4, -2, and B is at 0, 6. So we have A and we have B. So I'm going to draw my line connecting my 2 points, and then I'm going to find my slope. So I have y2 minus y1 over x2 minus x1. So when I find my slope, 6 minus -2 is 8, 0 minus -4 is 4, and this reduces to 2 over 1. So my slope is 2 over 1. Then I want to find two possible points that divide it into the ratio of 1 to 3. So what I want to do here is I want to look again at the non-reduced slope. So my non-reduced slope is 4 over 8. I'm going to divide by how many pieces I have. Well, 1 plus 3 is 4 pieces. So I'm going to divide by 4, and this again reduces to 2 over 1. So from the first point, from point A, I would go up 2 over 1 to get my new point. So my point then would be -3. This is R, -3, 2. -2. So R is x-axis. Then from B, I want to use the slope in the opposite direction that I just did. So instead, I want to go down 2 and right 1. So my S coordinate would be -1, 4.